our lesson. We're going to start with the real number system. Okay, this is something we should have all seen before. If not, it's not hard. We're just going to refresh that real fast and talk about it just a little bit. As I go, I'm actually going to write the official mathematician symbols, like the actual real math symbols that you use in higher level maths. You do not have to write those for the questions, answers, things like that. I just want you to see them at least once. They didn't ever pop up for me until I was in more advanced levels of math. The real numbers one did, but that's about it. The rest of them didn't appear until a little bit later. So if you're going to take a bunch of math classes at the higher level, so at college, you might see those symbols. And so I'm just going to show you to them at least once so you kind of have an idea. We're going to go ahead and get started. So for real numbers, okay, we use the symbol R, but it has a double line. And that one is just all real numbers. Can y'all think of an example of a non-real number?
0.
Mm-mm.
A fraction.
Mm-mm.
Integers.
Mm-mm.
Decimal.
Mm-mm.
Commas.
Mm-mm.
A negative.
Commas? Well, comma's not a number. But there is something called non-real solutions, which are imaginary solutions. Now, I'm not 100% sure how much of that we talk about in here, but I know in Algebra 2 you go into that a little bit more. Okay? So eventually we will learn about the non-real numbers or the imaginary numbers. But today we're going to focus just solely on our real numbers. And we're going to split our real numbers into two categories. It can either be irrational. And what it means to be irrational is when the decimal places never end and they don't repeat ever. Okay? So an irrational number example is what? What's a really, really common irrational number that you've heard a lot, but you don't actually even write the number when you write it? Pi. And another example of an irrational number would be the square root of 2. Does somebody got a calculator near them and they could do that?
You do.
I do. So let's look. Square root of 2. It is 1.4142135662. And that's just the calculator having to stop it because it can't put anything else on here. So because that fraction, that decimal is really, really long, right? We can't write it as a fraction. And so that means it's an irrational number. You can also have a negative irrational number. So negative square root of 101 would also continue on forever. And those are examples of irrational numbers. Then we're going to also look at rational numbers. I'll give y'all a second to write that if you hadn't already. For rational numbers, we've already used R for real numbers. So for rational, we're going to use Q. In the actual symbol, it will have little double lines in the sides like that. But again, if you just want to put a regular old Q, I'm perfectly fine with that. And if you missed any part of this, it will be on Schoology later today. Okay, so our rational numbers are numbers that we can write as a fraction. So 1/3, that's a rational number. Another way you could think about it is a decimal that ends. So negative 0.67, that's rational. You can also have things like the square root of 16, that's rational. Because what is the square root of 16? 4. Those of you that just came in, you can just pick up where we're at. And at the end of class, we should have time for y'all to copy down anything that's not down. And if not, it's on Schoology. Okay? And since the square root of 16 is 4, that makes it rational. What about something that has a repeating pattern? So we could do 0.3 repeating. And the reason that works is because 0.3 repeating is just 1/3. Okay? It can be written as a fraction. And so repeating numbers typically can be written as a fraction, which is why they're considered rational numbers. And a rational number can also be something like 3, -5. It can be a normal number too. Now, from there, inside of the rational numbers, there is another set of numbers called integers. We will use a Z for these. Okay, and integers, does anybody remember what an integer is?
Yes.
Give me an example.
-5.
-5 is a perfect integer. What's another one?
-10.
Yeah,
1.
yeah,
7.
yeah,
100.
yeah,
-10.
exactly. So we're going to put on here, we're going to start with dot, 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 comma, and we're going to do -2, -1, 0, 1, 2, and more dots. Because it can be anything from negative infinity to positive infinity as long as we're talking about an actual number. No fractions, no decimals, just an actual number. So like -782 is an integer. Positive 3,587 is an integer. Okay. -2,000,006,000 is an integer. Okay. Anything that can be written as a number, not a fraction, not a decimal, is an integer. Yes.
Oh, you answered my question.
Now, from the integers, that breaks down even more. And we're going to talk about whole numbers. Okay, whole numbers are 0 up. So 0, 1, 2, 3, and so on. So they are just the positive sides of it. Then we have natural numbers, which is n. And those are going to be 1 and up.
What's the difference between the whole?
Okay, so, well, a whole number will include 0. Natural doesn't. And the reason that is natural comes from the things that occur naturally. When you are talking about the number of trees, you're not going to say 0. Like, it's not something that, like, it's just really, really base numbers, okay? And then whole usually is more of, like, pure quantities of something, which you can include 0 there. And then integers goes to the negative side. And then rational includes all your decimals that can be written as a fraction and stuff like that. Then you have separately your irrational, which is everything else that's not categorized over here. Now, we're going to do some examples on these. So, if you did not get anything from when you were getting your computer, you can go ahead and write that down now, okay? Like I said, if we miss some stuff, we'll either have time to go back through it at the end, or you can get it off of Schoology. I'll get that uploaded today before I leave. But yeah, and so we're going to go ahead and look at those problems at the bottom once we are done. So our first question down there at the bottom is 30. What all is 30? Is 30 real?
Yes.
Okay. Is 30 irrational or rational? Rational. So far for 30, we have real, we have rational. Is 30 an integer?
Yes.
Yes.
Is 30 whole?
Yes.
Is it natural?
Yes.
So it's everything on that one side. It's everything except irrational. Because if a number is rational, it cannot be irrational. If a number is irrational, it cannot be rational. And it cannot be an integer. It can't be a whole. It can't be natural. Okay? Now, let's look at 2. Is 2 real? Or -11 real?
Yes.
Is it rational?
Yes.
Is it an integer?
Yes.
Is it whole?
No.
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 And if it's not whole, can it be natural?
No.
All right. For 3, we have 5 and 4/7. Is that real?
Yes.
Is it rational or irrational? It's rational because it's written as a fraction, right?
Yeah.
So we will use Q. Now, is that an integer?
No.
It's not. So it's only going to be real and rational. Make sure you pick that up, please.
I will.
Okay, now
No.
can we take the square root of 21?
No, cannot.
We can't. If we try to, it's going to give us a really, really long decimal. So what would that be?
Irrational.
So it's going to be real first, then it's going to be irrational. All of these numbers down here are real first. So if you want to. 5. It's real. Then what? Rational or irrational?
It's rational.
Okay. Is it an integer?
Yes. Yes.
Is it a whole number?
Yes.
Is it natural?
No. No.
Okay. For 6, is it real?
Yes. Yes. It is.
Okay. Is it rational or irrational?
Irrational.
It's rational
Why is it rational?
because it's just a negative number.
What's the square root of 9?
3.
3. And so it's going to be negative 3. Is negative 3 rational or irrational? Rational. Is it an integer? Is it anything else? What about 7? Is it real?
Yes.
Is it rational?
Yes.
Is it an integer?
No. No. Yes. Yes.
Why is it?
Because it's 2.
It's 2.
That just equals 2. So it is going to be an integer. Is it going to be anything else?
No.
Yeah, I heard somebody say yeah. What's it going to be? Anything else?
City California with the last name L as in Lance, or P as in Paul, to report the frequency time, L as in Lance, or P as in Paul, sophomore. Thank you.
Eli, put my seat down, please. Thank you. What about pi? What's pi? It's real and irrational. What about this one?
Rational.
That is actually equivalent to 16/3, I think. So if it's 16/3, can that be anything else besides real and rational? What about 10? It is real. Now what?
It's rational.
It's going to be negative 4.
Why is it going to be -4? And why is
Because
It's 12 divided by negative
negative 3.
and 12 divided by -3 is?
negative 4.
There we go. So it's going to be real. It's going to be rational. What else? Anything else? It can't be anything else because it's negative. What about this one? We know it's real. It is rational because it's a decimal that stops. Anything else?
Integer.
Can an integer be a decimal?
No.
No. So can that be an integer? No, it cannot. What about this one?
That's not low.
It's just 1.
It is just 1. Because what is anything divided by itself?
1 by 9. So it's everything, right?
So it is everything. Well, except for irrational. So it'll be real. It will be rational. It'll be an integer. It'll be whole. And it'll be natural. And then we'll flip to the back of this page. So the real reason I even bothered printing the back is for this little figure right here. Okay, so this whole rectangle represents what is considered our real numbers. And the way it's drawn actually shows which ones are a part of which ones. So like irrational is only a part of real because irrational is inside of real. Then natural numbers are included in whole numbers. Natural numbers are included in integers. They're included in rational numbers. And they're included in real numbers. Do y'all see that? Because it's in all of those. Whereas whole numbers can't be natural, right? Or they can be, but they're not always. What's a whole number that's not natural? 0. And then here, integers are a part of rational and they're a part of real, but are they always a part of whole? What is an integer that's not whole? -1. What's an integer that's not natural? There we go. Okay, so all this does is let us see which ones are a piece of each other really easily and really clearly. Now we're going to do these multiple choice questions. It says, which expression does not name an integer? A, B, C, or D? Which one? So if we look at D, what is 12 divided by 6? So is it an integer? Yep. So we have A is an integer, C is an integer, D is an integer, but B is not. Even if we simplify that to 3/7, it's still not an integer. Then on 2, it says, which one represents an irrational number? Is 0.18 repeating irrational? No. Is 2/3 irrational? Is the square root of 3 minus the square root of 3 irrational?
No.
What does that equal?
0.
Anything minus itself is 0. What about the square root of 75? Is that rational? Can you take that? So that is our irrational number. Then on the next one, it says, which number is not a whole number? 0 is a whole number.
-10.
-10.
Is all of these B?
Those 3 are. I don't think the rest of them are. For this last, why wasn't D?
Because you need to divide it down.
It'll just be 6.
Then we're looking for a true statement here. Is -9 a whole number? True or false? Is 0 a natural number?
No.
Okay, is 2/3 a rational number?
Wait, 2/3?
Yeah.
Yes, it is.
That's true. Is square root of 25 an irrational number? So which one is the answer to this question?
D.
And then 5 is asking us instead for a false statement. So are all real numbers rational numbers?
No.
No. Is every integer a rational number?
Yes.
Yeah. Is all natural numbers integers? Is every whole number a real number?
Yes.
So what's our answer?
A.
And that's all we're doing on that page. Flip to the next one. Nope, we're not doing it. Like I said, I will skip around some. It is what it is. Yeah. So we are going to talk first about absolute value. What does it mean to be absolute value?
A whole thing being 0.
Can't be negative. Because what is it talking about?
How far away it is from
Yeah,
zero?
how far from 0?
So we're going to put the distance from 0. And it is going to always be positive. And then we're going to do some of these examples. We're not going to do all of them, so don't panic when I skip around. Start with 1. Or do y'all need a second to write that? 'Cause I can. What is the absolute value of -13? 13. What's the absolute value of 21? So we've answered those two already. What do I need to do for 3?
It'll be 3.5.
Yep, because the absolute value is -3 is 3, plus the absolute value of -5 is. So what is that?
B.
And we're gonna look at 4.
17.
17. And the reason for that is because we have 9 plus 8. Then we're going to jump to 7. It's going to be 6. Why is it going to be 6? Yep. Why does this not change?
Because, wait, what do you mean why?
Because it's outside.
Is it inside the absolute value lines?
No.
No. We're not taking the absolute value of that one. Okay, so we get 11 minus 5, which is, what about for 10?
9.
Why?
It's 24 minus
24 minus 15.
And what is that? 9. And then, is there any 2 that aren't like the rest of these? 6 and which other one?
9.
How are they different than the one we just did?
Because the absolute, there's minus
There's no
inside the
separation,
absolute
it's just
value.
one.
Now, if I have a question, or I have a question for you, what would you do if this right here was just parentheses?
Minus
it.
That's the same thing we do right there. That's it. What is 21 minus 17?
4.
So we do the absolute value of,
I thought you meant
4.
positive. I mean, I thought you
we
meant-
do when the answer to the inside is negative. I'll show you. Okay, the reason for that is we are talking about inside that, right? So inside of that, there's stuff happening. We have to deal with what stuff's happening. So it's the same thing if I gave you this. What do I do first? Add them. No, because what if this was squared up here? What would I do first?
Still add.
You do 5.
Still add. What is 2 plus 3?
25.
Then I'll square it, which is 25. And the reason for that is squaring something is a type of function you have. Absolute value is also a type of function you can have. So you take care of what's inside first, then go outside. So what is 15 minus 23?
That's supposed to be a negative.
What is it? Negative 8. And what's the absolute value of negative 8? So our answer is still positive, but we have to do that subtraction in the problem first. Just like to square something, we have to add it together first. And that's all we're talking about with absolute value. Y'all feel okay about absolute value?
Yeah.
Any other questions y'all have on that one? Now we're going to talk about the order of operations. Do what? What'd you say? Yes, ma'am. So when we're talking about order of operations, we're talking about the specific order to simplify.
No.
And you just said it with a lovely mnemonic device. What was that? Please excuse my dear Aunt Sally. What does the P stand for?
Parentheses.
The parentheses part can also talk about any other grouping symbols. So if you have the other grouping symbols, we're going to actually write out all of them right here. It can be parentheses. It can be the square brackets. It can be the squiggly brackets. And it can even be absolute value. Those are things that group stuff together that we got to look at, that we got to make sure we see. What does the E stand for? What's next? What's after that? Divide. We're going to put those together. And the reason we do that is because when we multiply and divide, it doesn't matter what order multiplying and dividing you're in. Okay? You always go from left to right. And I'm going to show you why. So if we have a multiplying and division problem, this is also one of those things that really trips people up when they do this on the internet and they argue in the comment section. You know what I'm talking about? This is one of those things that trips people up.
On parentheses, what was the last symbol?
Absolute value lines. Just. Alright, so if I have this, let's see. If I do that. How do I do it?
You would do 6 divided by 2,
Mm-hmm.
and then you would get 3, and then you do 3 times 3 is 9, and then you do 9 divided by 6. I don't know what the answer is.
Okay, so, and the reason that works, the reason that we can just go left to right with multiplying and dividing is because I can technically rewrite this as 6 times 1/2 times 3 times 1/6. So because I can just write that all as one type of problem, I can just go left to right. We don't have to do that. We can use our order of operations. But that's why the order doesn't matter and we can go from left to right, because we can make all of them into the same operation. Does that make sense? So we can make them all the same operation, so we can just go from left to right. So you said 6 divided by 2 is 3, so then we have 3 times 3 divided by 6. What is 3 times 3? Divided by 6. What is 9 divided by 6? We're going to leave them as fractions most of the time. And can I simplify that?
Yeah.
How so?
1/3.
Or not 1/3.
3 and 1.
3 It would just be 3. It would just be 3.
1 and 1 half.
How many times can 3 go into 9? How many times can 3 go into 6? That technically simplifies that. Okay? But that's why we can do it in left to right order. That's also the exact same reason we can do addition and subtraction, and it doesn't matter the order. So if I did 5 minus 2 plus 3 minus 6, I can write that all as one operation. I can say 5 plus -2 plus 3 plus -6. It's all the same operation now, right? I made it all plus. It's just plus with negatives. Because you can rewrite it as the same operation, the order does not matter. Okay? What is 5 minus 2? And we have 3 plus 3. What is 3 plus 3? What is 6 minus 6? There we go. Okay? So these two, multiplying and dividing, and addition and subtraction, both go, it doesn't matter the order, they just have to go from left to right. My handwriting is really sloppy right now. I apologize. Normally it will be better. And we get out of here at 1:46, so we're actually going to do some examples tomorrow. That is your notes. You will keep it.